Okay, today we're going to do a repeated measures t-test, which is another way of saying a within subjects, within groups design, which means that we're going to have the same people in two different treatment groups. And for today's example, we're going to look at deer hunters and their ability to hit a target when they're sober and when they're hungover, because many deer hunters enjoy the occasional drink on the night before opening day. So here's their, we're going to just number them rather than naming them. There's when they're sober, and here's when they're hung over. So this is their ability to hit targets out of 40. So hunter number 1 is able to hit the target 16 times sober, 8 times hungover. Hunter 2, 28 times when he's sober, 24 times when he's hungover. Hunter number 3, 32 times sober, 36 times, whoops, hold on. "36 times hungover," so he's actually a better shot hungover. Hunter number 4, 8 and 8, not a very good shot either way. Hunter number 5, 20 times sober, 10 times hungover. Hunter 6, 31 and 18. Hunter number 7, 14 and 17. Hunter number 8, 38 and 32, our best shot so far. Hunter number 9, 12 and 10, and hunter number 10, 29 and 19. Okay, so our first step is going to be to come over here and set up our null and alternative hypotheses. So our null hypothesis is going to be that the mean difference is equal to 0, meaning that there is no difference in the hunter's hunting ability, their ability to hit the target, between time 1 and time 2, so between sober and hungover. The alternative hypothesis is going to say that the mean difference is not equal to 0. It might be greater than 0, it might be less than 0. We're not saying. This is a bidirectional hypothesis. So our next step then is to find the mean difference. And the mean difference is equal to the sum of the difference scores over n. And so let's put up our difference scores over here. So the difference between 6 and 8 is 8. 4, negative 4, we have to put that in as a negative. 0, 10, 13, negative 3, 6, 2, and 10. And so we sum these up, we get the sum of our difference scores, and we have to include the negative numbers in there, and so we can see that it sums to 46. So plugging the number into our formula, we'll just go this way. 46 over 10, because we have 10 hunters, and that is equal to 4.6. So that's our main difference. The next thing we have to find is our variance term, and that is equal to the sum of the difference scores squared minus the sum of the difference scores squared divided by n over n minus 1. And so we need this number. We need the sum of our difference scores squared. So we'll set up a new column over here, difference scores squared. 8 squared is 64. 4 squared is 16. 16, 0, 100, 169, 9, 36, 4, and 100. And so we can get the sum of our difference scores squared. If we add these all up, that's the international sound of adding things up, 514. So now it's again just a matter of plugging numbers into our formula. So this is going to be equal to, just to set it up, 514 minus 46 squared divided by 10 over n minus 1 is 9. So 514 minus 2116 divided by 10 over 9, which gives us 514 minus 211.6 over 9. This is becoming tiresome. Is equal to 302.4 over 9, which is equal to 33.6. Okay, now we need to find our standard error. So S sub d, and that again is equal to our variance term over n and under a root sign. So that is plugging the numbers in, we get 33.6 over 10 under a root sign gives us 3.36, and the square root of that is 1.83. Next is to find t, and t is equal to the mean difference over the standard error, and so we can just plug the numbers in here, 4.6, which we got right here, over 1.83, and t is going to be equal to 2.51. Next step is to find our degrees of freedom, which are equal to n minus 1, and so 10 minus 1 is equal to 9. Don't need my calculator for that. That allows us to look up our tree critical. With 9 degrees of freedom at 0.05, it's 2.26. So now we compare our t obtained to our t critical. 2.51 is greater than 2.26, and this allows us to reject the null hypothesis that there is no difference between the hunter's hunting or target shooting ability between when they're sober and hung over. So we can say statistically that the hunters are better when they're sober rather than when they're hungover. So we're able to reject the null hypothesis. And that is how you do a repeated measures t-test.